Welcome to Math 150, review for test 1, section 6. Solve linear equations in one variable by using the addition, subtraction, multiplication, and division properties of equality. Basically, that means you are allowed to do whatever you want to both sides of an equation. Remember, when we are solving an equation, we're looking to find all of the values for your variable x that will make the equation true. To do this, you rewrite the equation into equivalent forms until the answer becomes really obvious. For example, x equals 5. That's an equation that makes it really obvious. In the meantime, here we are starting with 1. Make sure that you copy the problem correctly, and then do whatever you want to both sides of the equation. I suggest keeping your equal signs lined up. Your goal is to get all of the numbers on one side and all of the variables on the other. So I'm going to choose to get all of my x terms on one side of the equation. So I'm adding 10x to both sides. Then this entire side simplifies to be 0 minus 50 or negative 50. And the right side is negative 56 plus 6x. Again, you can do whatever you want to both sides. My goal is to get the x value by itself. I don't want to divide by 6 yet. I could, but I'd rather not deal with fractions for the remainder of the problem. I'd like to get rid of all of these integers first. Now the right side becomes 6x. Oh, I'm not subtracting 56 from both sides. I'm adding 56 to both sides. So now I know that 6 is the same thing as 6 times x. At this point, I can tell x has to be 1. If it weren't so obvious, I would again do whatever I want to both sides of the equation until I have isolated my variable. Two different ways to do number 2. 15 is the same thing as 5 times the quantity, x minus 4. Yes, you can distribute, but you don't have to. This is multiplication. I'm allowed, and you're allowed to do whatever you want to both sides of the equation. So I've rewritten my equation to be 3 is the same thing as x minus 4. What I choose to do to both sides is add 4. So now that I see 7 is the same thing as x. So when I replace x with 7 in the original equation, I would have a true statement. If you distributed first, that would be fine. You would have 5x minus 20. Do whatever you want to both sides of the equation. I now have 35 is the same thing as 5x. My goal is to isolate the x. What's blocking that goal is multiplying by 5. So I choose to divide both sides by 5, and yes, indeed, you get the same answer. All right, I'm going to skip down here. I'm going to do number 3. 2 times the quantity x plus 6. In this case, I am going to distribute because if I divide by 2 or I divide by 3, I'll be dealing with fractions for the remainder of the equation. Not a problem, we could do that. It just takes me a bit longer, and sometimes I make silly mistakes with fractions. So I'll distribute. This would become 2x plus 12. You have creative license in math to rearrange and use anything that has the same value. I do suggest you keep your equal signs lined up. I like to have my x coordinate positive, so I'm going to subtract the smaller x value from both sides. Now I can do the same thing to both sides. I know after subtracting 2x from both sides, I am then going to add 15 to both sides. So I choose to do that all in one step. This left side here becomes 0 plus 27. This right side here, 9x minus 2x is 7x. So what I've really done is given myself 27 is the same thing as 7x. I need x by itself. What's blocking that goal is multiplication, so I choose to divide by the coefficient. I'm dividing by the number in front of my x. So 27/7 is the value of x that will make that equation true. 4. I'm going to distribute right as I write, no, 3 times the quantity 2x minus 3 minus 4 times the quantity x plus 5 is the same thing as 7 minus 2 times the quantity x plus 4. Remember, when you see this 7 minus 2, it's actually multiplied by the quantity x plus 4. This multiplication has to happen before the subtraction. Please remember your order of operation. I'm going to simplify or rearrange each side. So I'll distribute. 3 times 2x becomes 6x. 3 times 3 is 9. Positive times negative is negative. Now I have a -4. Remember, this negative goes with the number behind it. -4 times x would be minus 4x. And -4 times a positive 5, -20. 7. Now I have -2 or -2 times x. Positive times negative would give me -2x. -2 times positive 4 gives me -8. Keep your equal signs lined up. Simplify. These are my terms with an x. Notice the negative stays with that. 6x minus 4x becomes 2x. Minus 9 minus 20 means you're down 29. 7 minus 8 is -1. And I still have a minus 2x. Next step, do whatever I want to both sides. My goal is to get the x's on one side. So I'm going to choose to add the x's to both sides. I will add 2x to both sides. Again, my next step, I know I'm going to get rid of this 29, so I will choose to add 29. Notice plus 29 plus 2x is the same thing as plus 29 plus 2x. So now when I add this side, I'm left with 4x. When I add the right side, I'm left with 28. My goal is to isolate x. What's blocking the goal is multiplying by 4. So I choose to divide both sides by 4. And I find out that x is 7. This is my answer because most anyone can read this equation and know if x becomes 7, that equation is true. So what we've shown is that if x is 7, then our original equation up here will also be true. I'll do one more of these long ones. Yes, there will be long, challenging problems like this on the test. If you're hoping there won't be, you'll be disappointed because you will get to see something like this on test number 1. 12 times the quantity x plus 6 minus 3 times the quantity 5x minus 7 is the same thing as -2 minus 3 times the quantity 6x minus 5. I should clarify, there's a good chance you will see something like this on one of the versions of the test. I think these are excellent problems, and I think these should be on the test. All right, left side, distribute. Positive 12 times positive 6 is 72. Again, remember this is a -3. -3 times positive 5 is -15. Negative times negative is positive 21. minus 2, and then again, remember this is a negative 3 times the quantity of 6x minus 5, so negative 3 times 6 times x is negative 18x, and negative times negative is positive. Now going to simplify each side. 12x minus 15x would give me a negative 3x. 72 plus 21 is 83. Notice I'm trying to keep my equal signs lined up. Right side simplifies negative 2 plus 15. That would be a positive 13. So the right side becomes minus 18x plus 13. Do whatever you want to both sides. Show us what you're doing. I'm going to add 18x to both sides. I'll do this one in 2 steps. 18 minus 3 is 15. So the right side becomes 15x plus 83 is the same thing as 13. Next step, I would subtract 83 from both sides. Left side becomes 15x. 13 minus 83, one's positive, one's negative, so I need the difference. So if I'm not grabbing a calculator, then I'm finding the difference between 83 and 13, which is 70. So my final answer here is negative 70. The opposite of multiplying by 15 is dividing by 15. Let's scratch work over here. And then you can always use a calculator. 70 divided by 15 is not going to give me an integer. If I'm asked for a decimal, then I need to reduce. 70 and 15 are both divisible by 5. 70 divided by 5 is 14. And 15 divided by 5 is 3. So my final answer, x is negative 14 thirds. Leave it as a mixed, or this improper fraction is better than a mixed number. But in Alex, read the directions. One with decimals. 1500ths times the quantity A plus 6 minus 3500ths times the quantity A plus 2 is the same thing as 6/10. To solve this means to find the value for A, that when you plug that number in for the variable and do all the arithmetic on the left, you end up with the answer 0.6. I have no idea what that is, but I know I can distribute. So the left side becomes 1500ths A plus 9/10 minus 3500ths times A, and then 3500ths times 2. Negative times positive is negative, so I'd have negative 7/10. Combine negative 7/10 plus 9/10 is 2/10. So all I'm doing on the left is rearranging how this works, or how this looks. Combining those terms gives me the positive 2/10. (15/10) minus 3500ths All right, I'll rewrite this for a little more space. So I'm looking at this plus this is the same thing as this. Do whatever you want to both sides of the equation. Write down what you're doing so you and those who look after you can follow your work. Opposite of multiplying is dividing. I'm dividing by a negative 2/10. Positive divided by negative is negative. So my final answer is -2. Which means if you put -2 back into the original equation, do that arithmetic, you'll find out that it is 6/10. I'm going to show you another way to do the problem with decimals. You have creative license to do whatever you want to both sides. You can multiply both sides by a factor of 10 such that all of your decimals become integers. In other words, you can choose to multiply both sides. In this case, if I multiply both sides by 10, this will eliminate my decimals. So I now have 10 times 0.2 times 5x plus 1 minus 10 times 0.4 times x minus 5, which is the same thing as 5.8 times 10. So I multiplied every term by 10. When you're multiplying, you can multiply in any order. So I'll multiply those two numbers first, and I will get 2 times the quantity 5x plus 1 minus, and I'll multiply these two first, and I will have 4, and then I still have to multiply that by the x minus 5, and then 5.8 times 10 is 58. No longer have any decimals. Still have to distribute. This will become 10x plus 2 minus 4x. And again, this is a common place for mistakes. -4 times -5 gives you a positive 20. If you did this problem on your own before you watch the video, double check right there. That's the most common place for mistakes. Simplify the left side. I have 10x minus 4x is 6x. 2 plus 20 is 22. So now I'm going to subtract 22 from both sides. Opposite of multiplying is dividing. Final answer, when x is 6, our original equation will be true. Two different ways to deal with decimals. And I give myself more space on the next page. Seven eighths x plus 1/4 is the same thing as 1/2 x minus 3/8. You can clear the fractions, pick any number you want, such that when you multiply both sides of the equation, your fractions are eliminated. Looking at 8, 4, 2, and 8, the least common multiple, well, I can always multiply those numbers together, 4 times 2 times 8, and get a multiple. It might not be the smallest multiple. In this case, looking here, I'm recognizing that 8 would be the smallest multiple. If I pick the number 8, multiply each sides, all of my fractions will become integers. 8 times 7/8. Just write it out. 8 times 7/8x plus 8 times 1/4. 8 times 1/2 x minus 8 times 3/8. Keep your equal signs lined up. It helps you keep your work organized. And then reduce. This is going to become 7x plus 8 divided by 4 is 2. On the right side, 8/2 is the same thing as 4. If you're having trouble with multiplying fractions, please ask for help. Email me or your instructor. There we go. Again, do whatever you want to both sides. I'm going to subtract 4x from both sides. I tend to choose the smaller coefficient with my x variable, the term with the small, just because I want my answer to be a positive. So if my x's are going to be on the left side, then this plus 2 will be in my way. So I'm going to subtract 2 from both sides. This becomes 3x. And all of this becomes -5. So my final answer is -5/3. Blocking my goal is multiplying by 3. One moment. Opposite of multiplying by 3 is dividing by 3. I'll do one more. This one both. 1/3 x plus 5/9 is the same thing as x minus 2/3. Give myself a little more space to show what we're doing on both sides of the equation. Looking at my denominators, 3, 9, and 3. If I multiply both sides by 9, I will no longer have fractions. I'm writing my value of 9 as 9/1 because I think it's easier to multiply fractions by fractions rather than fractions by integers. So this becomes 9/3 x plus 9 times 5/9. Same thing as 9x minus 2/3 times 9/1. I wrote it that way because I intend to reduce. 9 divided by 3 is 3. 9 times 5 is 45. 45 divided by 9 would leave me with 5. Minus 6. Need the same thing on both sides of the equation. All the variables on one side, all the numbers on the other. I'm writing down what I'm doing to both sides of the equation so I don't make silly mistakes. Keeping my equal signs lined up. This side simplifies to be 11. This side simplifies to be 6x. Now the only goal in my way, only number blocking my goal is 6. So I'm now left with x is the same thing as 11/6. Last example. 2/15x plus 1/3 is the same thing as 2/5 x minus 1/3. Looking at my denominators, 15 would be nice to use. If I multiply both sides by 15, my fractions turn into integers. Keeping my equal signs lined up so I don't make silly mistakes. This is 15 times 2/15, which will reduce to 2, plus 15/3 is the same thing as 15 times 2/5 times x minus 15 times 1/3, which is 15/3. And keeping these equal signs lined up. Right now, I'm just rearranging what's on each side. I'm simplifying each side. That reduces to be ones. 15 and 5 are both divisible by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. So I'm left with 2x. 15 divided by 3 is 5. 3 times 2 is 6. Do whatever you want to both sides. I'm going to subtract 2x from both sides. So then I'm going to add 5 to both sides. Strongly recommend you write down what it is you're doing to both sides of the equation. Left side becomes 10. Right side becomes x. Now, for this step, we're going to divide both sides by 4. 10 divided by 4 can be reduced. So 5/2 would be the final answer. Questions or comments? Let me or your instructor know.